Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps and the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so we've got a angles crossover question. We've clearly got the diagram to look at. They've also given the information from the diagram in worded form. So this isn't additional information, it's information that we can already see. If you're not someone that's brilliant at angles, then a top tip is to use your tracing paper that you're allowed in your exam and literally trace the diagram. That way you've got a spare copy of the diagram that you can scribble all over, try different ideas out on. But also the drawing action helps you spot things that you might not see when you're just looking. So physically drawing it out does help you see more of the information. Okay, we are trying to find X. And the first thing that I'm going to do is use the 76. I can see that the 76 is sitting on this parallel line. So if I follow from this parallel line up to the next parallel line, then I know this angle, which is 76, will tuck in with this angle here. So I know that is 76. I've been told that I have to give reasons for my answers. So I'm going to write them out as I go. So I've used alternate angles. I know it's alternate because I've got that Z shape. And I've used this notation here, BAC. That means I've started at B to A to C. Those two lines create that angle. All right, so that's the notation that I'll be using throughout. Now I'm going to focus in on this 54. They've given it to me, so it must be helpful. That 54 is inside this triangle with the right angle. So I'm going to use that to help me find this angle here. So 180 for a triangle, take away the angles we know, gives us 36. And I'm marking this on the diagram so I can clearly see it. I now have everything I need to work out x. I can see that all the way across is 76. This little bit here is 36. So 76 take 36 is the mass. And that is my answer. Okay, so Jenny is organising a party. She buys some paper plates and some plastic cups. So we've got a lot of information here and it's all very wordy. So I'm literally just going to put the information into a more mathematical way, just because it's easier for my brain to cope with that. So they're sold in packs. So there's my pack. There's 25 in a pack and they cost 78 pence each. And I'm going to do the same for the plastic cups. So we've got 35 in a pack and they cost £1.10. And I'm already clocking that I've got different units here and I will need to be mindful of that, I'm sure, at some point. Jenny wants to buy exactly the same number of plates and cups, exactly the same. So I need to be considering the multiples of 25 and 35. Now, it is a calculator paper. I can use my calculator to help. I can just list them out. That's another way of doing it. But I need to find that lowest common multiple. Okay, so I can see 175 is the number that's common in both those tables. I had 7 in order to get to 175. So I would be doing 78 pence. Now this is where I'm going to change into pounds. So I know that 175 plates will require me to buy 7 packs at a total of £5.46. Doing the same with the cups. This time timesing through by 5 because I only need 5 packs. And it's £5.50. To finish it off, we just add. So £10.96 is our final answer. Okay, there are only red beads and green beads in a bag. The ratio of red to green is 5:9. So I'm just going to pop that there so it's clear and easy for me to see. I don't have to look at that sentence again now. What fraction of the beads are red? So we've got 5 that are red out of a total of 14 that are there. There is a total of 84 beads. How many of the beads are green? So if I've got red to green being 5:9, in the ratio, I have a total of 14. In the story, I have a total of 84. How do I get from 14 to 84? I times by 6. So I would do the same on this side. Now I only need to do the green. So 9 times 6 is 54. So 54 green beads are in the bag. So Susie is going to put some more beads in. They will still only be red and green. So we know we're not having a different color. She wants to have twice as many green as red in the bag. So what beads should she put in? What do we know already? We know that we've got red and green in a ratio of 5:9, and that there are 30 red and 54 green to make that 84. Now, at this stage, she is adding more so that she has twice as many green. So if we look at the red, there's 30. For there to be twice as many, we need 60. And to get from 54 to 60, we would need to add 6 more green. Okay, so we've got information about the average adult spend in 2008. In May 2008, Katie spent a total of £425. She spent £48.45 of the 425 on food, and we've got to compare the percentage of that in the table for the average adult. So we'll set this up as its fraction. So £48.45 out of her total 425 is what she spends on food. Obviously, I don't want a fraction. I want a percentage so that I can make a comparison. So I'm going to times that through by 100. Calculator tells me 11.4%. So Katie spent 11.4%. I need to compare that with the average adult. The average adult spent 11%. So Katie spends 0.4% more. Okay, this is one of those questions where if you just had your starting number, it would be really easy. It says in February, they sold twice as many houses as in January. So if you had January's number, you'd know February's. In March, they sold 10 more houses than in February. Again, if you had January, you'd have February, which means you'd have March, and so on. But we don't have a number for January. And in maths, when you don't know the number, you use algebra. So this is a sneaky little algebra question. So in January, they sold X or N or H for houses. It doesn't matter what letter you use, but they sold an unknown number of houses. In February, they sold twice as many. So that would be 2 lots of this number I don't know. In March, it's 10 more than February. So February's number plus 10. And in April, they sold half as many as in March. So we can just half that expression and we've got a number for April. We're told that they sold a minimum of 123 houses. So let's add up all of January, February, March, and April. And we know that that expression is linked to the 123. So we've got 6x plus 15. Now, we're told they're sold a minimum of 123. So it could have been 123, or it might have been greater. So we're going to be using this symbol, and then we're going to solve in the normal way that we would solve equations. So we're going to take off the 15, and then we're going to divide through by the 6, and we've got the least number for January as 18. X was allocated to January, so we're finished and we're done. Okay, so we've got a semicircle and a circle that have created this shaded area that they want us to find. Now, there are a couple of ways that you can work around this problem to get to the answer. So I'm obviously just going to demonstrate the one that's obvious to me, and that's how we do our maths. We do the one that we can see within the problem. Now, I'm actually considering this section of the diagram only because this section of the diagram has my shaded bit. So I'm kind of going to ignore this side. So in the problem, I've got a quarter of a very large circle. So I've got a circle here with a diameter of 20. That's the original semicircle. And I only want a quarter of that circle. I want this section here. So I am going to be doing pi r squared, which gives me the area of a full circle, but I'm going to divide it by 4 because I only want a quarter of it. Now I need to be careful. I've got the diameter, not the radius here. So I need to half that. So I've got pi times 10 squared divided by 4. And that gives me 25 pi. Now I could change that into the decimal, but if I do that, I've got quite a complicated number to then have to work with. So I'm just literally going to leave 25 pi as it is for now. Now I'm going to look at the circle. So I've got the circle, which has a diameter of 10, and I want all half. I want all of that section. So that is going to be pi r squared divided by 2. Now remember to use your radius, and that gives us 12.5 pi. Now to get the shaded region, I'm going to be taking the quarter And it's almost like imagining try and use my lights. You're taking this quarter and it's almost like they're punching this out of it so that it's gone and you're left with this shaded area. So the last step is to take away. So we've got 25 pi, take away 12.5 pi, which is going to give us 12.5 pi. And now I'm going to look at my decimal, which is 39.269. On and on it goes. They're asking my answer to be to one decimal place. So my final answer is 39.3 centimeters squared. Okay, so we've got to work out what Asif has done wrong. So we know he's made a mistake and we need to spot it. I personally think the best way to try and spot an error is to just do the question yourself. So if you rewrite it to the side, and you can see the first thing he's done is expanded the bracket. So let's do the same. That would give us 3x, and 3 times 4 would give us 12. And you know what? We don't have to do any more work because we can already see his error. He's added the 3 and the 4 instead of multiplied it. And that's what we would write down. Okay, Sam invests £5,000 at 2.8% compound interest for 4 years. Now, if you've seen any of my other videos, you will see me doing my 2-tick test. So this is no different. I've got a percentage, and compound interest means I've got that increase. So this will be original times multiplier equals result. My job is to get that multiplier. Okay, so to do an increase multiplier, you just add your percentages to get a total percentage. I don't work in percentages, so I divide by 100 to get the decimal version. So my original is 5,000, which I times to 1.028. Now I just need to pause because I have another number to consider. I have a period of time. A period of time is always attached to the multiplier as a power. So that 4 will go here, and then I just pop that into my calculator and I round it for money. Okay, Andy invests 12,000 in a variable rate compound interest account. He's getting 2% for the first year, 3.5% for the second, and 5% for the third. And we've got to work out his after 3 years. Now, we have to be careful here. It's really tempting to just add all of these up and work on it as a whole, but you mustn't do that with percentages. We are literally going to have to do each individual year, step by step. We'll do our multipliers in exactly the same way. So we've got 12,000 as the initial, times that through by the multiplier, which would work out at 1.02 to give the amount of money at the end of the first year. And it's that which goes in to our second year. And then you just repeat it for the third year using 5%. And that would be your final answer. Okay, so I've been given some information about a rectangular lawn with a path around it. And I'm told that the total area of the lawn and the path is 100 meters squared. I've got to show this piece of algebra, which will get created by doing the total area of the lawn and the path as 100 meters squared. So let's see what that means. We know it's a rectangle, so we're going to be doing this length multiplied by this length. This length here is 3x plus this, so 3x plus 2. And our height is 2x plus 1. And we know that they need to be multiplied in order to represent the area. So you'll use your crab's claw, your grid, your foil, whatever method you use, and you will get the following. which tidies up to... Now, we know that that is the area expressed in algebra, but we also know that the area is 100, so that equals 100. So I'm getting really close to what they want me to show. It needs to equal 0, not 100. So I'm going to move the 100 over to this side in order for it to equal 0. 2 take 100 is minus 98. And I've just shown what they have asked me to do. I'm now being asked to calculate the area of the lawn. For me to be able to do that, I am going to need to work out a value for x. So my quadratic equation is 6x squared minus 7x minus 98 equals 0. I could consider factorizing. However, it already, to me, with my experience, looks like something that's not going to factorize particularly easily, if at all. The numbers are quite large. I've got a calculator. It makes much more sense to just go straight into the quadratic formula. If you are taking your exam in 25, 26, 27, it is on the formula sheet, so you don't have to commit it to memory, which is fantastic. So A is equal to 6, B is equal to minus 7, C is equal to minus 98, and I'm going to substitute all of that into the quadratic formula. Okay, I've got everything in its place. Be really careful when B is minus 7. I often pop it into the brackets like this so I can see that double negative. Here, if you're going to throw it all in the calculator, the bracket's really important, or it's actually going to give you a different result because of the way the calculator's programmed. So be really careful of that. I'm going to tidy some of that up so that it's a little bit clearer and neater as to what I'm looking at. Okay, and then I'm going to split that plus and minus. This gives the following results. I've got 14 over 3 and I've got negative 7 over 2. Those are the two results that the quadratic gives me. I will be rejecting this result because it is negative, and you can't have a length that is negative. So I know that 14 over 3 is the value for x that I need to use, okay? Now they're asking me just to find the area of the lawn. So it's important that I clock that and don't do the entire rectangle. The lawn is 3x times 2x. So we've got 3 times 14 over 3 times 2 over 14 over 3. And I can pop that in my calculator and get my final answer there. Okay, so we're being asked to complete the table of values for the y equals x squared minus 4x minus 2, and then draw the graph. If you know how to do this in your calculator, then use your calculator. If you don't, then that is something that you really want to learn because it's super, super helpful. If you don't know how to do it, you're going to be doing it the long way. So you've got y being equal to x squared minus 4x minus 2. If I do this section of the table, I'm being told x is 3. So that's going to give me 3 squared minus 4 times 3 minus 2. And when you work that through, you get a result of minus 5. So you can pop that into the table. You would then repeat the whole process with the next missing value. I've used the calculator, so I can just fill them all in. We then have to take the coordinates that the table gives us. So that end one, for example, x is 5, y is 3, and we will plot that onto our graph. And we will go through and plot all of those coordinates and draw in the graph. Okay, now you can see that I have not gone through absolutely perfectly, but I have done a good enough job to get the marks. They want to see that you are trying to draw a curve, so make sure it stays curved at all times and it runs through. Sometimes just turning the paper around and doing it at a different angle makes it easier to do that drawing. Now there is a part C. We've got to use our graph to estimate the values of x when y is equal to -3. The line y equals -3 is here on our graph. Our values are on the x-axis where these cross each other. So I would literally just be going up and reading where they come in. So x is 0.3 and x is 3.7, I would say I've got on that graph there. Now, they do allow a slight range because you have to remember, if this is being drawn freehand, then yours might not look exactly like mine, and therefore our results may differ slightly. So if you've had a answer between 0.2, put the point in, and 0.4, that would be acceptable, and 3.6 to 3.8 would be acceptable. Okay, we've got another percent question. So tick, I've got a decrease right there. So it's got the 2 ticks, meaning it is original times multiplier equals result. Now I've got to consider the context here. I can't change the fact that it's a decrease. So my multiplier would be 0.88. Remember, we do our 100, take away 12, and then divide through by 100. So that's my multiplier. The sale price of the camera is £132.88, and I want the normal price. I want the original. So the original is what we're trying to find. We know that whatever that number was, when it got multiplied by 0.88, it was equal to 132.88. And then hopefully you can see, to find the answer, we're going to just need to divide through by 0.88, which is equal to 151. So this gives the structure to help us get the value they give us in the right place. It's only got 2 possible options. It's either the original or the result. Okay, so we've been given a tetrahedron and being told that AD is perpendicular to both AB and AC. And they've shown this on the diagram as well by putting in those right angles for us. We've been given some of the edges and we're being asked to work out BDC, which is this angle here. Now, if we consider the triangle that BDC creates, we aren't anywhere near the right angles. That looks like a right angle, but we can't assume that. And we don't have any numbers. None of the values that they've given us link to these edges. So we're going to need to use the information to help us get some of these edges to start off with so that we can go on and find this missing angle. It's going to be advanced trig because we can't guarantee that that is 90 degrees there. Okay, let's have a look at the first one. I'm going to use a highlighter here just to really show what I'm working on because that might be useful. I'm going to find this missing edge using this right angle triangle. And of course, it's going to be Pythag. We've got 2 of the edges and we're going to find the third. So DC will be found by doing 5 squared plus 8 squared and then square rooting the answer. That gives us root 89. And I'm not going to go into the decimal. I'm just going to leave it like that for now because it's a nice, precise, exact number. Now, dB is going to work in exactly the same way. dB is here, so it's coming off of this triangle. So that gives me root 125. And I'm in a position to be able to find that last edge as well. So I can find this one using my 10 and my 8. Okay, I have found all 3 edges on the triangle that contains X. I'm actually going to draw this out separately now so that I can really see clearly what I've got to help me solve this problem. So my X is here. I've got root 125 on this edge, root 89 on this edge, and root 164. And as I've said before, I'm leaving them in their root so they're exact and precise numbers. Using the formula sheet, I can see that this problem is going to be the cosine rule. I've got my sandwich, which is what I always look for. X is sandwiched between these two edges, and I've got the third edge as well. So cosine all the way. I'm going to copy it down from the formula sheet, and we're going to have that formula sheet right up to 2027, which is nice. I'm now going to substitute in all of those values. Now, before I do, I'm just going to show you something quickly. A is root 164, and it's going to be that squared. The root and the square cancels out, which will take me to 164, which is brilliant. So I'm going to understand that that is going to happen here as well. But it doesn't happen here because I don't have the power 2 in the formula at this stage. Okay, I'm going to tidy that all up a little bit, do some of the maths. And I'm going to just start rearranging to get cos A on its own. I would just say be careful not to lose this negative. Cos A is being multiplied by negative 10 root 445. So be careful not to lose that. That's easily done. This side becomes 0.237 and on it goes. And now to finish it off, to find A, I just need to get it on its own so that cos is coming across. It's going to land as its inverse. I'm just using my answer key on the calculator. I don't need to shorten it. I don't need to round it. I can put the whole thing in, and I'm getting 76.289. On it goes. Check with the question. It wants it to one decimal place. So the final answer is 76.3 degrees. Okay, so we've got a story about a machine part, and we've been given the diagram of that part. We're told that the perimeter of the small square is 2/3 of the perimeter of the large square, and eventually we need to work out the length of a side of the small square. Well, let's go back to that line about the perimeters. The small square is 2/3 of the perimeter of the large. So let's work out what 2/3 of the perimeter of the large square actually is. So the edge of the large square is 3x plus 4. For the perimeter, I want to times that through by 4, which is going to give me 12x plus 16. I want 2/3 of that, which is going to give me 8x plus 32 over 3. So you just expand that bracket, use your calculator to help, and that is 2/3 the perimeter of the large square. And I know that is equal to the perimeter of the small, which is 4x plus 16. So just 4 lots of its edge. Now I'm just going to go on and solve the equation that I've created. So I'm going to take the smaller set of x's, move it across. It's a positive number landing as a negative number. So that's going to give me 4x plus 32 over 3 equaling 16. I'm then going to take off the 32 over 3, which will give me 4x equals 16 over 3. And remember, we've got our calculator, so none of this is particularly tricky. We're going to be using our calculator all the way through. So to finish off, we're dividing through by 4, which is going to give me 4 over 3. Now that's the value of x. We're being asked to work out the length of a side of the small square. Now remember, the small square is x plus 4. So we've got 4 over 3 plus 4, which gives us an answer of 16 over 3, or 5 1/3. Either answer, you could put it in as, sorry, a third might help if I write it properly. Either way is fine. And you can also obviously write it as its decimal as well. Okay, so Carolyn has 20 biscuits in her tin. We've got information about the types of those biscuits. She's going to take at random 2 of the biscuits from the tin, and we got to work out the probability that the 2 biscuits were not the same. Okay, so it could have been a plain with a chocolate or a chocolate with a ginger, but what it cannot be is a plain and a plain, or a chocolate and a chocolate, or a ginger and a ginger. Now, when I think about all the outcomes, there's 3 that I technically don't want, and there are going to be a lot that I do want. I can draw a probability tree diagram in full and I can find all of those out. But being a little bit on the lazy side, I'm going to use the fact that all of the combinations, and I know you can't see them all on the screen, but all of the combinations would equal 1. So if I do 1, take away PP plus CC plus GG, it will give me all of those combinations without me having to find them all. So it's a much quicker, more efficient way of doing it. And I'm also going to be super lazy and not draw out the entire tree. At the start of the problem, she's got 12 plain biscuits out of a total of 20. So her probability of picking a plain is 12/20. To pick her second plain, she's only got 11 left out of 19 left. And they're all going to work like that. So the chocolate would be 5 out of 20, followed by 4 out of 19. And the ginger would be 3 out of 20, followed by 2 out of 19. I multiply across a tree diagram, so these will all get multiplied. I'm just going to rewrite this so it's clear what's happening. And I get the results 132 over 380, 20 over 380, and 6 over 380. And of course, your calculator might very well give you those cancelled versions. I like to kind of stay in the full numbers until I'm kind of at the end of the question, if I'm honest. Together, these add up to 158 over 380. So we're going to communicate that and show clearly what we're doing to our examiner. And then we're going to do that 1 minus trick, which just saves us so much time. And obviously, if you put a cancelled version of that down, it is perfectly acceptable. Okay, so we're looking at an equilateral triangle. We're told that the area is 36 centimeters squared, and we've got to find the value of x. So we know that the angle must be 60 degrees. And obviously we know the area. Now, if we think about the area of a triangle, we would automatically think base times height divided by 2. That's really going to let us down here. We don't have the base, we don't have the height. We're unable to use that. So we're going to go to our formula sheet and we're going to find the advanced formula, which is a half AB sine C. That will find us the area of a triangle. And we know that that formula in this question is going to give us 36 because the area of the triangle is 36. This works in the same way as our cosine rule, where we have that sandwich. So this is our sine C angle. And this is A and B, which we can clearly see are both labeled as X. So we've got half times X times sine 60 equaling 36. If we put the half times sine 60 into our calculator, we're going to get root 4, and then we've got x squared equaling 36. And now we can just start to unpick this in order to get that x on its own. So I'm going to multiply through by the 4. I'm then going to divide through by root 3, and then just square root to finish off. Check how they want it. They want it 3 significant figures, so it would be 9.12 as our final answer. Okay, we're going to prove algebraically that the product of 2 odd numbers is always, and it's in bold, so It is always an odd number. We have to clock the word product. That means times. And we have to know how to write two odd numbers in algebra because we're proving it algebraically. Now, the way that we do that is we write an even number. Any number that is multiplied by 2 will be even. So 2n guarantees me an even number. If I then just add 1, it will push me up the number line one place and it guarantees me an odd number. So that is one of my odd numbers. The other way that I could have done an odd number is gone down the number line one place. So I've got two different odd numbers represented. They are going to get multiplied together because we want the product. This is going to give 4n squared minus 4n minus 1. And we now just need to explain why the expression we've got will give us an odd. So the way that I would do this is I would point to this. I can see that no matter what n is, it will be a multiple of 4. And all multiples of 4 are even. So I would write that down. I'd then take a little look at the next one. And again, I've got that multiple of 4. Now, this here is an even number, take away an even number. Or you could say it is a multiple of 4, take away a multiple of 4, which is always going to give even. Always gives even. We've then got a minus 1 on the end. So I've got even at this stage, and then I've just got a minus 1. Well, that is going to equal odd. So I've used my algebra and I've explained my algebra to make sure I've communicated clearly how I've proven it will always be odd. It isn't the only way to set up your expressions. You could do two different letters, 2n plus 1 and 2m plus 1. I personally would always avoid more than one letter wherever possible because it just makes the whole communication harder to deliver. So where you can, on a proof, keep your letters the same. That would be my kind of top tip, really. Okay, so we've got a car approaching a set of traffic lights. The traffic light turns red and it takes the car 4 seconds to slow down to a stop. And that's what the graph is showing us. And we need to work out an estimate for the distance the car travels in that stopping time. Now, the distance is the area under the graph. So I need to work out the area, and I'm going to do that by creating chunks. So I'm going to split the first second off of the rest of the graph. I've got a nice rectangle, which is really easy to work out the area of. 1 times 20 is 20. So that section is going to be 20. I'm then going to split it off at the 2. And you can see that I've got this curve, which is going to cause me a real issue. I can't manage that, which is why they're saying that I'm estimating the distance. What I am going to use is a trapezium. I was to join those two lines together. You can see I'm pretty close on that curve with that. And I've created a quadrilateral that is a trapezium. So I will be using the trapezium formula to work out this one. I'll do the same for this one. And again, we'll just draw it on so that we can see it. And then we'll talk about this one, because if I go to 5 seconds, then I've got 0, which means I no longer have a quadrilateral. Okay, so here I can't use 0. I could see this as a triangle, and I could work out using a triangle, or I could just use a very small value for my trapezium, like 0.1, and continue using a trapezium. I'm actually going to do both so that you can see the maths. Okay, so you can see the trapezium gives me 5.1. The The triangle gives me 5. There really is very, very little difference. So I'm going to stick with the trapeziums and call that 5.1. And I'm going to add all of those together to get my total under the graph, so that I've got my total distance, which is 47.6. And if I'd gone with the triangle, I would have had 47.5. There is a range that is allowed here, which is 46 to 48. Now, part B is asking us, is it an underestimate or an overestimate? And it's actually going to be over, as the trapeziums do cut just above the line. And you can see it a little bit clearer on this one. Obviously, that one would show it better still. So it's an overestimate because the trapeziums used connect above the curve. Okay, so a farmer wants to estimate the number of rabbits on his farm. On Monday, he catches 120 rabbits and he puts a tag on each rabbit and then he just lets them run away. So we've got 120 rabbits out of a number we don't know that now have tags. On Tuesday, he catches 70 and 15 of these rabbits have tags on them. So 15 out of the 70 caught have tags. Now, the number of rabbits remain the same. All right, they've not changed between Monday and Tuesday. So proportionally, these fractions will equal each other. So I can set that up. It's a bit like a cancelled fraction. Okay. To solve this, I'm just going to multiply through by the 70 and then multiply through by the x. Divide through by that 15 and x is equal to 560. So that's using an algebraic way to finish it off. But as I just said, this is like a cancelled version. So what I could have done is just thought about, well, what do I times by 15 to get to 120, which is 8, and 70 times 8 is 560. So that might have been an easier way of doing it, but I wanted to show obviously this because this is going to work no matter how complicated things get. And it's a grade 9 question, so we shouldn't be feeling at all worried about that type of maths. But if there's a more efficient way of doing things, why wouldn't we do it? Okay, that's it. That is paper 3 of set 1, all done. The entire set is available now. So if you've jumped in on paper 3, then do go and practice papers 1 and 2 as well. Get your total score, and then you can use the grid at the end of the video to give you an idea of what grade you're currently working at. All right, well done, and hopefully I'll see you in one of our other videos.